Hi everybody, it's Miss John Baptiste. Today we're going to learn about Sir Isaac Newton's laws of motion. So if you look at the first slide here, you can see that he was born in 1643 and died in 1727. He was a scientist and a mathematician, and he's famous for his law of gravity or the three laws of motion. So there are three laws of motion. Today we're only going to talk about the first one, but I will read all three. So the first law of motion is an object in motion will tend to stay in motion, and objects at rest will tend to stay at rest unless acted upon by an unbalanced force. The second law of motion is force equals mass times acceleration. And the third law of motion is for every action, there is an equal and opposite reaction. So let's talk about this first law of motion. And again, he said an object, anything that is at rest, that means it's just sitting there. It's going to stay at rest. It's just going to keep sitting there until an object or an unbalanced force is acted upon it. If an object is moving, it's going to keep moving until an unbalanced force acts upon it. So what does that mean? Well, an object is just going to keep doing what it's doing. And it's going to keep doing that forever until an unbalanced force acts upon it. So if an object is sitting still, it's going to stay stationary. That means it's going to keep sitting still. If an object is moving at a constant velocity, it's just going to keep moving at that constant velocity. The only way it's going to change is if a force acts upon it. So what's an unbalanced force? Well, here we have a picture. It shows like a physics book, or let's just say a textbook, sitting on a desk. The desk is actually pushing on the book, and gravity is actually pulling on the book. So put your two hands together, and if you push both of them together equally, right, they're not going anywhere. Okay, your hands are going to remain the same if they're both pushing together. That's a balanced force. An unbalanced force is when one side has more force than the other side. So that makes them unbalanced. So here's some examples in real life. So let's say you have a soccer ball and it's at rest. It's just sitting there. It takes an unbalanced force of a kick to change its motion. So if someone comes up and kicks the ball, that is now an unbalanced force, and the ball goes moving in the direction it's kicked. If two teams are playing tug of war and they are both exerting equal force, that means it's equal. Both sides are both pulling the same amount in opposite directions. That's a balanced force. And guess what's going to happen? No one's going to go anywhere. No one's going to move. If we take one of the kids out, and it's 3 against 2, now we're going to have an unbalanced force because the 3 people will have more strength and pull those 2 kids on the other side. Newton's first law of motion is also called the law of inertia. So make sure you write this down, inertia. And that's the tendency of an object to resist changes in its state of motion. So imagine, let's think about that tug of war game again. And we take away that kid on one side. Those 2 kids are probably going to lose that tug of war, but they're going to resist it. They don't want to be pulled. So they're going to dig their heels in and pull as hard as they can. They're going to try to resist the change. So the first law states that all objects have inertia. So the more mass of an object has, the more inertia it has, and the harder it is to change the motion. So imagine if those two kids on the one side, one of them weighed, 120, and the other one weighed 350 pounds. The kid that weighs 350 pounds has more inertia. That means the kid has more mass. It's going to be really hard to move that kid. So those three other kids on the other side, they may not win the tug of war game because they don't have as much mass or inertia. So let's take a look at the slide with the car here. First of all, don't let this be you. Always wear your seatbelt when you're in a car. Because of inertia, objects, including you, resist change in their motion. So if you're moving forward in a car, your body wants to keep moving forward in that car. If the car suddenly stops, bam, it slams their brakes. What does your body do? It yanks forward. Why? Because your body wants to continue moving forward. So if the car is going 80 miles an hour and is stopped by a brick wall, guess what's happening to your body? It's going to keep moving at 80 miles an hour. So if you don't have a seatbelt on, your body is going to go through that front windshield at 80 miles an hour. Because according to Sir Isaac Newton, your body is in motion and it wants to continue in motion. And that's why seatbelts are so important. So here's some more examples. You always ask, why do we need to know this? Well, here's another example why it's important to know the laws of motion. So you have a powerful locomotive, which is a train, and it begins to pull a long line of boxcars that were sitting at rest. So you have all those cars that go after the engine. And they're all just sitting there. Since the boxcars are so massive, they're so big, they have a great deal of inertia. And it takes a really large force to change their motion. Once they are moving, it takes a really large force to make them stop. So on your way to school, a bug flies into your windshield. Since the bug is so small, it has very little inertia, very little mass, very little inertia, and exerts a very small force on your car. So small that you don't even feel it. So you might see that bug smash into your windshield, but you don't feel it because it doesn't have a lot of mass. Now, can that bug push your car away and survive? Absolutely not, because your car has so much mass or inertia, and that's why the bug splats on the windshield in front of you. Now, if the objects in motion tend to stay in motion, why don't moving objects just keep moving forever and ever and ever and ever, right? So if you roll the ball down the street, how come that ball doesn't just keep rolling forever and ever and ever? Well, things don't keep moving forever because there's almost always an unbalanced force acting upon it. So if we slide a book across the table, it will slow down and it will stop because of the force called friction, right? When you rub your two hands together, right, that creates friction. When you have a book rub across the table, the book and the table, the rubbing together is friction, and it's going to slow it down and eventually stop it. If you throw a baseball upward in the air, guess what? It's not going to keep going up in the air and out into the universe. It's going to fall back down. Why? Because we have a force acting upon it, gravity. So gravity eventually is going to pull that ball back down to the ground. So imagine we're in outer space and we're away from the gravity and we're away from the sources of friction. And a rocket ship is launched with a certain speed and a certain direction. It's going to keep going in that same direction forever and that same speed forever, unless an unbalanced force acts upon it. Now, why does that not happen? Because we have the engines and we allow it to turn and to move. We don't want to send astronauts into space in a rocket ship, right? And they just keep going forever and ever and ever, and never ever stops. So this is all I'm going to say about the first law of motion. Again, an object in motion is going to keep going and going and going until something acts upon it, an unbalanced force. An object that's at rest or just sitting there, it's going to stay there until an unbalanced force acts upon it. So I hope you understand the first law of motion. If not, ask me some questions in chat or hit me up during the email time from 1 to 3. And make sure you do your assignment. And tomorrow we'll work on the second law of motion. Have a great day.